guys. Welcome to the first ever virtual Be a Scientist program. I'm one of the mentors, Alyssa, and I'm here to tell you a little bit about myself and what I do as a scientist. So I am a fourth-year graduate student at UC Berkeley. So I'm getting my PhD in molecular and cell biology. But what I like to do outside of science, and when we're not in quarantine, is I really like to get outside. So here's some pictures of me on my very first backpacking trip. I really like running races. I think that they're a lot of fun. I absolutely love Yosemite National Park. Whenever I'm home, I like baking and making different treats for myself. And I also really like being adventurous. And so I've shared a picture of me bungee jumping here. But what I do in science is I study in the Miller lab this fish called the three-spined stickleback fish. And what's really interesting about this fish is that they can replace their teeth over their lifetime. So if we think about us as humans, we have our baby teeth that develop when we're a lot younger, and then they fall out, and then our permanent adult teeth come in to replace them. And then what happens when our teeth fall out again is they don't grow back, right? So you have to make sure to take good care of your teeth. However, with the three-spined stickleback fish, they regenerate their teeth over their lifetime. And so here I have a little picture of what this fish looks like. And so there's this three little spines on the top of the fish. You can't really see well in this picture. And then I have a fish that's actually has a green fluorescent protein in it, so it allows it to have that fluorescent protein throughout its body. And then in this bottom panel, I actually have images of tooth development over time. And so you have this budding stage, a capping stage, and you go through early and mid-belt, and then finally having a functional tooth with a little baby replacement tooth underneath it. And this process, going from bud to replacement tooth, happens throughout their lifetime. And what we found, just kind of looking at other systems of regeneration as a model, is that how the tooth regenerates is very similar to how a hair regenerates. And so then it leads us, as scientists, to ask questions like, oh, okay, well, as humans, our hair regenerates, for most of us at least, throughout our lifetime, where, our hair falls out and then it grows back. So why doesn't that happen with our teeth? And similarly, why is it that we don't have, hair growing out of our teeth or teeth growing out of our hair? And what's kind of controlling that on a DNA level? So one of the things that's really interesting about this is just that transformation process, right? Of going from a bud to a replacement tooth, or a regenerating hair follicle. And how does that change happen? And it's one of the things that got me first interested in studying science, was looking at early development and how you go from having, a sperm and an egg, they fertilize, and then through time and development, you end up having a baby, and then that baby grows to be bigger, and you have all of these different specialized cells and organs that contribute to a fully functioning human being. And so as a part of this video, I was asked to give you guys, a challenge question, and something that I've been doing at home with respect to, transformation and change is actually growing this little garden here. So here I have a bunch of little plants that I started growing at home just because I really love this idea of transformation over time. And so these guys are only maybe about 2 weeks old, and you can already see just how big they've gotten over time. And so my challenge question to you guys is to find examples of transformation around your home or outside of your home, and maybe take pictures of it every day so you can see the change over time. And I'm excited to see what you guys come up with and what we're all going to share with each other. And I'll see you guys soon. So, bye.